Hey guys, and welcome back to another YouTube video. In this video we are going to be continuing on our neural network game controller project that we had started. So in the last video what we did was we created the actual neural network. So I'm just going to quickly open up that file and just show you the code again real quick. So I'm just going to quickly do that. So as you can see, we wrote this code in the last video, all of this. And in this video, we are going to be creating the Opencv interface for this project. So, first what I'm going to do is I'm going to just comment. You know what? No, it's okay. I thought that I would get rid of the testing directory and stuff, but it's okay. So, now that we actually have this, we have actually saved our model as controller neural network 1.0. So that's what we are going to be using. So now what I'm going to do is I'm actually going to create a new file called interface.py, and I am going to open up interface.py, and I am also going to just set the line number and set a color scheme. So we are going to be making a few imports. So first of all, we are going to need TensorFlow as TF and Keras. So from TensorFlow import Keras. We are also going to need NumPy as NP, and from TensorFlow.keras.models we will need to import load underscore model. Besides that, we are also gonna be needing CV2, Opencv, for this. Now I am gonna be referring to some code that I have already written to do this. The reason being that I am a little iffy on this code, so that's why. So first of all, we obviously need to define the class names. So in this case, the class names that were available to us, what I'm gonna do is I'm just gonna have one extra window open uh, as a reference. So cd desktop slash python, and where is that? And then okay, I can't find it. Alright, I think I'm just gonna copy paste the name of this website. I'm sorry, this folder. CD alright, there we go. So now we are gonna just cd to dataset and ls. So we have jump and we have normal. So these are gonna be our class names. So I'm just gonna open this up. So we have jump and we have normal, and those are our class names. So the next thing that I have done is we actually need to load in the model. So loading in the model. So model is equals to keras.models.load underscore model, and then here we need to specify the model that we want to load in. So over here, as you can see, this is the model that we had saved, and that's what we wanted to load in. So I will simply just say command, oops, what did I do? Okay, don't want to print this, cancel, command V. So now I have just I want to load in this model, so I'll just pass that in over here. So I'm just gonna save it. Now currently obviously there are no errors in the program, so yeah, that's pretty cool. So now what we need to do is actually, okay, I think I have a little bit of an error over here, so I'm just quickly gonna change this. So otherwise I will end up copying this and will end up with an error. 0. Now we actually need to get the video feed. So getting the Opencv video feed. So I just say video underscore capture is equals to cv2 dot video capture 0. Now in case if you have like an external webcam, like you are running a computer and you have attached an external webcam, then you don't want to type 0 out, you actually want to type out 1. The reason being 0 stands for the default webcam that you have on your machine, and 1 stands for any external webcam. Now in case if you are using a security camera or any camera like that, it gets a little bit more complicated, since you will need to actually set up an RTSP protocol, and you'll actually need to put in that RTSP URL over here. So you will need to check that out. You will have to check out the IP address of the camera that you are using, and then you are gonna have to set just add that IP address. You're gonna add the username and the password of that, and you're gonna have to then just test it on your VLC media player. If you get a video feed, then you have to take that URL and you want to paste it in the video capture. So I know it gets a bit complex. So then we can just say while true, we just want to, now I'm just gonna be copy pasting a little bit of this code. And you know what, I think just so that this thing looks good, I'm also gonna do one more thing. I'm just gonna go to neural networks, and over in the live face mask detector, I actually had the Cascade for the frontal face, and I'm just gonna add that to neural network controller over here. I'm just gonna add that, so it also detects the face while doing the other things, which is pretty cool. So I'm just gonna go up over here, and I will need to copy a few things, just this. So I'll just say y, and we will have to, oops, you, command B. Alright, what just happened? Wait, I think I'm just gonna copy that directly. Alright, there we go. So here we are just loading in the Cascade classifier. This will actually allow us to detect and draw like a square around us. Now I'm sorry that I'm copy pasting the code, but that's just because it gets a bit complex, and I don't want, and I will kind of like make a ton of mistakes, so that's why. So yeah, so copy that. Actually no, I will need to, alright, so I need to add this code over here. So let's go to visual, copy that. I don't think that worked. Yeah, it didn't. Okay, what just happened? I don't know. I think I typed in an incorrect command or something. Alright, I think I'll just have to manually do it. You know what? I think I'm just gonna go WQ and just open it up in VS Code, and I think that will simplify some things here and there. I'm just gonna copy paste a few things. So I'm gonna need to copy this. Now the reason why I don't use VS Code is because since I'm recording VS Code, I have a ton of extensions and stuff in VS Code, so it gets a little system heavy if I record and I also do other things, so that's why. So now what else do I need to do? oh yeah, I need to just add this code in here. Cool. So no detection till now. Then we just define a face list. Then we just loop over the faces which we have defined up over here, and we get the face frame. Then we just resize it to 300 by 300, which is incorrect since the image dimensions that we were using were 150 by 150, and we also are doing the predictions. Now we need to print out the predictions, so we'll just say print class underscore names np.arg max prediction. Actually, I called it preds over here, so just call that. And now that we have done that, I need to do a few more things, which is this. So I'm just gonna copy this code, and we are just simply gonna paste it there, and let's just save it, and we can actually run it now. So alright, I'm just gonna close my standard terminal and open this up. Alright, we want to run interface.py, so I'll just say python 3 interface.py. Come on, it's taking a long time. You know what, let me just try running it over here on my standard terminal. Maybe it will be a bit fast. There we go. So we just want to run interface.py, copy that, python 3 interface.py. Let's just stop this from running. Now for some reason it's taking some time to run. There we go. Image to array isn't defined. Alright, I think we can work with that. Let's have a look. Okay, so we need to import this image to array. So I'm simply gonna take this and add this line over here. Let's save that and run this again. And let's see if it works. Alright, so currently it's saying jump for some reason. And okay, why isn't it drawing the thing? Wait. What if I actually raise my hand? Is it gonna say normal? So it means I actually screwed up something. So if I raise my hand, it's saying jump. And if I lower it down, so it isn't saying normal for some reason. It only says jump. Now that's a bit of a issue. So we need to work on that. I think I know what the issue is. with this. I think it's only doing the prediction once, because it's predicting the face frame, uh, whereas, so yeah, converting that, expanding the dimensions, pre-process input, face list dot append face frame. So how exactly do we do that? So we are appending it to the face list. So the thing that I want to predict is something gonna be like the last index of the face list. So maybe what I can do is just say faces underscore list dot reverse, which is equal to faces underscore list, and I want to predict the faces underscore list 0th index. Let's try this out. And you know what? Right now I'm just gonna print out threads, and untype has no object, so subscriptable. Alright, so this means that since there is no list right now, since it's all just, it's empty, so that's an issue. So you know what, I'm just gonna say face frame, and let's see if there is something. Let's say face frame, and we can also just get rid of this line of code over here. Yeah, and I'm also just gonna do one more thing. I'm just gonna add like a print out this over here, and I'm just gonna print out backslash n. Alright, let's have a look. Okay, so for some reason it's only printing out jump, whereas it shouldn't be doing that. And even if it is printing out jump, the main issue is that it's like, as you can see over here, the predictions are this. 1 second, if I just raise my hand over here, what's the issue though? So like, it's either that the model is terrible, or there is a bug in the Opencv code, and we need to figure out what is the case. Now the most what do you say, probable thing is that there is a bug, the model is bad, but like for some reason I just can't get it. So if you look at it, this is literally the code that I've already used and I have basically copy pasted. So this shouldn't be happening right now. Let's figure out something. See what I am right. No mask index frame. So is it all in there? So what we can check is if we are writing it out. Where are we writing? So we are checking the frame. Now let's see where have we referred the frame. cv2.putText, cv2.putText frame. Alright. Alright, so I think I get it. What I'm gonna do now is I'm just gonna say over here, before I actually get the prediction, I'm just gonna say cv2.imWrite, and I'm gonna give it a few things. have I defined it? I'm just gonna say test. uh, what else do I have to give it? No mask plus dot jpg, test dot jpg, comma, the face frame. And let's just go and run this file now. So with this we will actually understand what's the deal with the cv2.im write. So like, what face am I actually predicting? That's something that is incredibly important. So okay, why isn't it saving anything? It should be, but it isn't. Okay, why isn't it? Come on, cv2.im right. Maybe I want to. Where do we want to actually do this? So you know what I'm gonna do is I'm actually just gonna do it over here, right after we actually define the face frame. So I'm just gonna add it over here. Alright, let's have a look now. The reason being, if we don't do this, the character will just keep on jumping. And okay, there we go. So as you can see, we are getting predictions as normal. So that means that the OpenCV code that we had is working. And so is the model. It's just that the model is incredibly bad at predictions. That's the thing. So as you can see over here, if you look at test.jpg, the image is constantly being updated. And if I just do something, as you can see over here, if I'm doing this, the image, as you can see, I'm getting predictions as normal, 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 jump, normal jump. So as you can see, the model is just terrible at predictions. It's not that it's not like that we have a bug in the code. It's just that the model isn't very good at predicting things, and that's something that we can work with. It's not something that's you can't fix. Like if this was going to be a bug in the OpenCV side, then that would have been a bit of an issue, since tracking it down would not be the easiest thing, to say the least. So this is good that now that we have actually tracked down the source of these issues, we are actually gonna be able to fix it in some way. Now if you look at it, it's not printing out normal now. Now it's again all just jump, jump, jump. Okay, there we go. It does say normal. All right, cool. So now we know that the model is uh, working. It's just that it's not good, which is something we can work with. Like initially, if you don't know, in the last video, I did say that if the model architecture that we were using initially didn't end up working and matching my expectations, then I will modify it, which is something that I think we will have to do now. So I think that's one of the things that I think I'm gonna do, but I don't think I'm gonna do it on camera. I will show you the code, but I won't run the model, since it will take a long time. So that's why. But right now, let's figure out if we are able to first just get the interface all up and running. If we can get everything perfect, like, then it's just a matter of improving the model's accuracy, which is surely something that, well, we can figure out how to do. Like if I can get everything done, then uh, I think improving the model accuracy, it's just a matter of playing around, tuning the hyperparameters, choosing the correct ones. So it's not really a big of a deal. It's surely something that we can figure out. So right now what I'm gonna do is I'm first gonna get the boxes being drawn around my face whenever there is a detection. That's something that I'm gonna get done first right now. So let's just do that. All right. So how exactly do we want to do that? Let me have a look over here. How have I done that? So we are just drawing a rectangle and putting text over there, right? So all I need to do is just add that over here. Just do that, paste that, oops, copy that, and undo this and command V. Awesome. Let's just do this, and I think I pasted this in the wrong place. What I'm gonna do is I'm just gonna go to visual mode, cut this, and oh come on, I messed up a ton of things by doing that. Oops. Visual mode. Okay, come on, man. Alright, there we go. Finally. And I'm just gonna go up top and I am gonna paste it here. And you will see in a second why I'm doing that. CV2 text, and the text is gonna be equal to this. So that print statement that we had made earlier. And I'm just gonna save it in a variable called label. And I think that is it for actually showing up that rectangle. Let's run that script again, and if everything is correct and working, then we should get it. Alright, color isn't defined, obviously. That was a stupid error. Let's define a color over here. I'm gonna make the rectangle red. You can keep it any color you like. It isn't anything specific, but one thing that you should keep in mind is that the color should be an RGB code. You can't just type out a color, so that won't work. Alright, now let's run this again and hope that it works. Color is not defined. Where else have I defined color? Alright, I got to define red over here. Now let's run it and see if it works. Come on. There we go, and it is working. So right now it says jump, but let's see if it goes to a normal anytime. Come on, give me a normal. Wait, is it something like I've screwed something up with the model? No, I haven't screwed up anything in terms of. Alright, it isn't able to get me a normal prediction right now. It's only giving me jump. That's a bit of an issue. It's okay, we can fix it. You know what I'm gonna do is something that I did do initially. I think I'm just gonna do 5u. Actually 5u will be too less, since the way Vim undoes things, it's pretty bad. It's like it only undoes a single character at one time, which is annoying to say the least. So I'm just gonna paste it over here and do that, and we will just select the rectangle, and we will just paste it at the bottom. we'll just paste it at the bottom over here, and there we go. I think that is perfect. We also not printing out the label. That's something that we should just do to see if we aren't screwing anything up again, because you know how programming is, we can be making bugs. Come on, give me a normal prediction. Why isn't it doing that? Alright, it just isn't giving me a prediction as normal, which is okay. There we go. Okay, so for a second it did give me a prediction as normal. Okay, let me actually have a look over here. It did give me a prediction as normal. It was just for one single frame, but it was there, so that's a cool thing. Where was it? Somewhere over here. Now that we are printing the label out, I think it will be a bit more helpful. Jump, 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 jump. Come on, give me a prediction as normal. Give me normal. It just isn't giving it a normal prediction. I don't know why. It just isn't. Okay, there we go. We did get normal. We did get normal. We did get normal. But it's again back to jump, but we did get normal as a prediction. That's kind of good. There you go, we are getting normal again. We did get normal, which is, you know, that's good. We do know that the model is working now, which is something that I did want to check. Because if the model wasn't working, like when I say model wasn't working, I mean, I'm sorry, if the actual interface wasn't working, then that would cause a lot of issues. But now we actually do know that the interface is working, it's just an issue with the model. So that's not a really big issue, because it's just the accuracy and not the actual like bug. It's not a bug, it's just it's the accuracy. It's pretty low. So now we have the interface in place, and let's see how long that took us. Okay, longer than I expected, but you know what, it's okay. So now that we have this in place, what do we need to do now? We need to actually create the game. Now, this is where things get a little bit complicated. So, currently, the way we are getting the predictions is we are doing this. Uh, like we have this Opencv interface. Now, how exactly do you communicate this Opencv interface with a Pygame window, considering both of them are gonna be in different files? And that's where things get a little bit complicated. And that's what I need to kind of figure out, because that's the main issue. So I think like my first what do you say, way method of doing this would be have a file, open up a file and just type out the most initial prediction, then have the Pygame window continuously open up that file and be reading stuff in there, and then executing it. Now that would be my first approach to doing this. And you know what, let's actually try it out. Let's see if we like, not compromising the frame rate, without compromising the frame rate, are we able to do something like that? Because that's something that's a big concern. Okay, now I am gonna have to Google that up. I don't really remember syntax really quickly. And alright, okay, I don't know why my Mac is lagging a whole lot. I think I'm just gonna quit my VS Code. I think that's what causing the lag. Alright, there we go, that's what's causing the lag. And let's just search up opening a file in Python. Open a file in Python. I just don't want to open the file. I also want to write something to the file, which is something that we need to figure out how to do. Yeah, we want to do that. Oh, come on. Now now this website will just freeze. I don't know why that's the case. Out opening and writing to a file, and writing to a file in Python. Python read and write to files. There we go. That's exactly what we want. Using JSON text binary files .csv.text. Oh, come on, I don't want this boring theory. Let's get into the code. Alright, there we go. So we open it up, we read it up, and alright, so no file or directory, try and catch. Come on, I want to read and write. Okay, so I think we want to open it up in read and write mode, not just write only mode. Actually, no, we only want to open it up in write only mode. We don't even want to read the file, because you use R to the default mode to read the files. Another case, when you want to write or append, you use W or A. Now in this case, we don't want to append anything to the file. We want to write stuff. So we want to get rid of things that were already in the file, and we just want to write things to it. So yeah, as you can see, it does say open the file for writing only. File pointer placed at the beginning of the file overwrites the existing file. So that's exactly what we want to do. We don't want it to you know, add multiple labels, because then we'll have to do some algorithmic stuff to figure out the final the latest label, and it will get a little difficult. So I'm just gonna put it up in a try and accept block real quick. I think I'm just gonna do this, and we are just gonna paste it here. Alright, that just really messed up with the indentations. I think I'm just not gonna do that. Dude, what is happening? You. Come on, man. Vim is seriously pretty bad if you forget some of these things. Oh, come on. Alright, let's see if I haven't broken up any of the code, because we did make a few changes here and there. Come on, run. Alright, let's have a look. Okay, there's no issue. There's no issue with the code. So we just want to open it up, right? Alright, where do we want to do it actually? Yeah, I think we should do it over here only. So prediction underscore file is equals to open prediction underscore file dot text, and I want to open it up with a W, and I want to write to that file. So file dot write the label, and I just want to say prediction underscore file dot close. And I think we'll have to create it over here, so I'll just say oops, command C. How do you do that? Okay, I'm just gonna do it through my terminal. Touch prediction underscore file dot txt. Prediction underscore file dot text. And let's run the file. I'm pretty sure there will be some error, but let's have a look. like I really want to get the interface done in this video so we can focus on actually building the game in the next video. All right, so well, it didn't throw me an error. Wow, that's pretty cool. uh so yeah, let's just quit this and open up the prediction.txt file. All right. That's working. Cool. That's so cool. All right, but we need to check if it does append, like it doesn't remain constant. So let's actually uh, run this now. We have our prediction file right over here. All right, it's taking a second, kind of expected. uh, but all right, there we go. So let's open up the prediction file.